Hi guys, welcome to my video on geometric sequences and series. So the first thing that I want to talk about is what is the difference between a sequence and a series. So if you notice in both of the examples that I have written here in the chart, the numbers are the same, but a geometric sequence is a list of numbers and a geometric series is a sum of those very same numbers. What makes the sequence or the series geometric is that there's a common ratio in between any term to the previous term. So if I take a look at the example I have here, this number 64 divided by the previous term, which is 256, reduces to a ratio of 1/4. And if I do that again with the next set of terms, 16 and 64, 16 divided by 64 is also 1/4. And I can keep going and show that that ratio doesn't change. 4 divided by 16 reduces to 1/4. So that tells me since this ratio is constant, that number that you see 1/4, that's equal R.
So that ratio
or the
being
common
constant
ratio
is what
of the
makes the
sequence or the
sequence
series.
geometric.
Okay, so there's two rules. The rule for a geometric sequence you have probably seen before. That states that the nth term, a sub n, is equal to the first term, a sub 1, times the common ratio raised to the power of 1 less of the term that you're looking for. The next rule is for a geometric series, which I'm going to take some time below to develop for you, because that's a rule that maybe doesn't make so much sense. So we're going to develop it algebraically. It's a little bit advanced, but I believe that you can do it. So the first thing that we're going to do is we're going to talk about what does a sum look like. So a sum, we're going to call the sum S sub n, is really just all of the terms added together, right? So I would say the first term plus the second term plus the third term, and so on and so forth, all the way up until I get the very last term. We're going to call that a sub n, okay? But in order to develop this formula, I don't see all of those extra terms in there. So I need to come up with a different way to write what all of these middle terms are. So there's the first term. To get the second term, I would really take the first term and multiply it by whatever the rate was, right? And that I can kind of see from that formula in the geometric sequence. The third term, I would take the first term and multiply it by the rate 2 times, which would square the rate. The third term, I would take it and, or the fourth term rather, I would take it and multiply by the rate cubed, and so on and so forth, all the way up until I get that very last term that's actually the explicit formula, a sub 1 times r to the n minus 1. So this is a more general way, this line is a more general way of writing that a sum is all the terms added together, okay? So what I'm going to do to this formula, that last line that I have, is I'm going to multiply every single term by r. So r times S sub n, r being the ratio, the common ratio, and then r times, and I'm just going to offset it a little bit so you see, but r times a sub 1, so that's multiplying this term times r, plus r times a sub 1 times r would give me the same as the previous term, r sub 1 squared, and then a sub 1 times r squared times r would give me r cubed, and so on and so forth, all the way up until I get a sub 1 times just r to the n. And what I'm going to do is subtract that off of the previous formula. And that gives me S sub n minus r times S sub n is equal to the first term. And then if I notice, if I take this term and subtract off that term, those cancel. These two terms are the same. Those are going to cancel. Those are going to cancel. So those are all zeros. And that will continue to happen all the way up until the very last term that doesn't cancel, a sub 1 times r to the n power. Okay, so I'm going to use my knowledge of GCFs to kind of simplify this a little bit. I noticed that S sub n is a GCF on the left side of the equation, and that would give me S sub n, or the sum of 1 minus of a series, is equal to a sub, and then all of this is gone, right? So I don't need any of this, and 1 minus GCF of my remaining terms is a sub 1 To get them back, I would do 1 minus r to the n. Okay? And then to get the sum, 1 divided by r, 1 divided by r, I would get that final formula that S sub n, or the sum of all of the terms in a geometric series or sequence, would be a sub 1 times 1 minus r to the n over 1 minus r. So that's just a development of how we get that formula that we have been using. So here's a quick example to go over everything you should know so far. We're going to consider the sequence 6, 24, and 96, and 384. And we're going to figure out what the explicit formula that represents the sequence is. So the first thing I'm going to do is write down what the formula is, which is a sub n is equal to a sub 1 times r to the n minus 1. So I know that this is a geometric sequence because the problem states it, but I need to know the common ratio. So I'm going to do that by dividing one term by its previous term. 24 divided by 6 is equal to 4. And then checking that that still works. So 96 divided by 24, that's equal to 4. And then lastly is 384 divided by 96, that's also equal to 4. So that means that my common ratio is this number, which is 4. Okay, so that means that my explicit formula is a sub n is equal to the first term, which is 6, times the common ratio, which is 4, raised to the n minus 1 power. And that's going to allow me to find any term that I want within the sequence, which takes me right to number 2. So number 2 is asking to determine the 11th term of the sequence. So that means that I want to find a sub 11, which is equal to 6 times 4 to the n minus 1. So the 11th term that I'm looking for, minus 1. So basically, this term means that I'm using that ratio 4. I'm using it 10 times, 1 less than the first term. So 6 times 4 to the 10th power, which is 6,291,456. Okay, so my very last question is to determine the sum of the first 100 terms of the sequence. This is why we need to know what the sum formula is, because you certainly wouldn't want to figure out the first 100 terms and then add them all together. So S sub n is equal to the first term times 1 minus r to the n over 1 minus r. Which is equal to the first term. The first term that we used here had been 6 times 1 minus 4 to the 100 over 1 minus 4. So you can use your calculator quickly to calculate that. 1 minus 6 times 1 times 4 to the 100 over 1 minus 4, or negative 3. And that is a very large number, because again, these numbers are increasing exponentially. So that final answer is 3.21 times 10 to the 60th power, which means 60 decimal points after the decimal in 3.21.